My name is Alejandro.
My name is Adam.
This will be our second project for our vibrations class, and this is the video that corresponds to it. So first, we'd also like to give a credit to Professor Young UIC for the slideshow format.
For this project, we were asked to set up a non-rigid body structure and explain the vibrations, the experimental versus the theoretical data, the error, and what we learned. But first, it's important to mention that at the beginning, we were working with a paint stir stick, but we decided to change it to a plastic ruler instead because of the stiffness.
And of course, that makes sense because if we look at the structure model, vibration model, free body diagram, and inertia diagram, they're all going to be the same. The only difference is that something with a lower stiffness, like the ruler, will allow us to actually record the motion and get it on track. And speaking of, this is what that data looks like, which is exactly what we want to get. Higher peaks at the beginning, lower peaks at the end, and they're oscillating near zero at that ending point.
For this project, we used MATLAB to calculate everything. There were no hand calculations involved. And we found that the model mass is 0.002155, and the equivalent stiffness is 33.9002. And our experimental data, we found that the damping ratio to be 0.000521. From there, we were able to calculate our values of the natural frequency, and we found that the theoretical is 19.61 and the experimental 17.297. And then this is our plot right here, where we can see that the theoretical peaks are higher than the experimental ones.
And of course, that refers to what we learned, which totally makes sense with the plot that we've given. Because if we really think about it, not only in this experiment did we learn how to use tracker, the coding with MATLAB to ensure that everything is well, but also we see the analysis of just allowing one degree of freedom in this grid for non-rigid body, right? And really, what we did when we set it up, as you saw at the beginning, is this. And what we really should have done is not less, because we're essentially violating the small angular assumption. So if we look at our data, at our plot, that's exactly what we see. That in the theory, it should be a lot less than what we actually did because it should be oscillating less because of the small angle. But in short, right, if we were not to violate that rule, it would have looked a lot more similar. And what this allows us to do is that next time we do an experiment that is like this, we can set it up in such a way that it doesn't violate these rules and assumptions that we set up for it. And hopefully it gets the data closer to it if our calculations are good.